Hello everyone, I'm going to talk to you today about how an electrical message is propagated down the length of a neuron from the dendrite all the way down to the axon in order to be able to stimulate the terminal ends of the axon to release neurotransmitters into the synapse. To understand this, we really need to remember that a neuron is just part of a larger scale, part of an entire nervous system that can help transmit some sensations as pain or temperature or pressure. In this case, with the lesson, we're concerned with pain, and in order for that pain message to be sent, an electrical impulse has to start at the dendrite and propagate its way down the axon. So to do this, we also need to zoom in to a larger scale when it comes to the axon itself. We have to remind ourselves that, like any cell, there is a phospholipid bilayer that surrounds the entire axon, and across this bilayer is what the ions are going to travel. Within that bilayer, there are channels, and the channels I'm representing here by toothpicks that will open and close to allow for the movement of ions. In particular, the ions that we'll be concerned with are sodium ions, represented by white-colored beans, and potassium ions, represented by black-colored beans. We also should remember the fact that the membrane potential in millivolts, it should be an MV, at rest, is highly negative because of the numerous amounts of negatively charged proteins inside of the axon. However, there are positively charged potassium ions inside of the neuron at rest, and they will play a large role in helping the neuron recover from its stimulated state and to be able to generate a new action potential. Also, just outside of the axon, there are a large number of positively charged sodium ions that I'll be representing with these white-colored beans. Again, it's a three-dimensional construct in the real world, so that'd be entirely encompassing the neuron, but I'm just going to represent this dimension for the sake of our review. So just put quite a few in here just so that we have them. Now, for an electrical message to move its way down the entire length of the axon, there would be opening and closing gates all along the process to propagate the electrical charge and the action potential. So please keep that in mind. So upon stimulation, what would happen is there would be a message sent to the axon, which would start the process without actually opening up the gates of allowing some sodium inside. And this helps us understand how it is that threshold is reached. So as some sodium ions leak into the axon, the general change in membrane potential is an increase from negative 70 millivolts at rest to about minus 50 millivolts. This is what we'd consider to be threshold. Now, threshold is important because at threshold, the sodium channels will open up. And by opening up sodium channels, again, which open up at threshold, there is a huge surge of sodium ions, positively charged ions, into the neuron of this process of the nervous system. So this movement of sodium ions in from a largely sodium ion filled outer space will cause the membrane potential to surge quickly up to a membrane potential of about positive 50 millivolts. Now, this positive 50 millivolts is also important because in addition to propagating the electrical message down the length of the axon, it also opens up the potassium channels. Now, when the potassium channels are opened, this allows movement of positively charged potassium ions out of the neuron, and in a sense, moving these positively charged entities out, the membrane potential returns to a more negative resting state. So again, positive are going out, the membrane potential is becoming more negative. Now, in order to allow the membrane, the neuron rather, to fully recover, a third gate, if you will, or pump is opened up, and by opening up this third pump, the potassium is pumped against the concentration gradient back inside of the neuron, and at the same time sodium is pumped again against its gradient back. So potassium are pumped back inside, and sodium is pumped back outside of the neuron. And by pumping sodium again through the sodium and potassium pumps, the repolarization of the neuron is accomplished, and the gates being closed as well, neuron is back to a rest state. At this point, the neuron can be stimulated again, and the action can continue. And so, as the electrical message is propagating down the length of the neuron, gates are opening and closing all along the way to facilitate the electrical message, which would ultimately release neurotransmitters and start the process all over again.